Hello everyone, my name is Vibhav. I work as an open source integrations engineer at Uffizzi. Today I'm going to talk about CI/CD interoperability using CDEvents. So what do we mean by interoperability even? Interoperability is where multiple systems can work together to get the desired result. There are two types of interoperability. The first one is direct or structural. The second is indirect or semantic. In the direct or structural interoperability, as the name suggests, there is the way they are working together, the multiple systems are working together, is the structure of each system is known by the other system. So a good example would be Docker Compose to Kubernetes deployment, where the structural interoperability will be implemented by a tool like Uffizzi, where the conversion to the deployment from Docker Compose or to like the Kubernetes service will be done by Uffizzi itself. This is direct translation from one format to the other. Semantic interoperability, as the name suggests, is there is semantics between the systems are known by each other, and each system leverages those semantics to broadcast what they are doing in a eventing sort of way, which is then understood by the other systems, and there is no need for each of the systems to know the format of the working format of any of the other systems involved. A good example of indirect or semantic interoperability is CDEvents spec, which we'll talk about more today. Multiple CI/CD systems know, or when they consume CDEvents spec or they translate their events to CDEvents spec, these events would be known by other CI/CD systems. So CI/CD systems wouldn't have to really know what they need to do if they need to trigger like a pipeline on another one. All they need to know is how do I broadcast what I have done as a CDEvent spec, and then that's the end of it. So one CI/CD system just broadcasts the CD event, and that CD event would be known by another CI/CD system. Let's delve a little deeper into how we can make CI/CD systems more interoperable. One way to do it, which we're going to talk about more in depth today, is eventing. Eventing allows us to implement indirect or semantic interoperability without in a really good way, without knowing the structure of each of the structural formats of each of the CI/CD system and implementations. Hence, we can be decoupled. If one CI/CD system goes down, there will be others, and then we wouldn't have to rely on just one CI/CD system. And considering it's decoupled, we can still continue with our work that way to be fault tolerant. And once, if the CI/CD systems themselves scale through the architecture, we can still be sure that all of the eventing will work through, because eventing itself is a very scalable solution. Now, the problems that come along with this is there will be like too many formats. Each system will give out different kinds of events which might not be known by the other system. There would not be a proper language that can be known by each of the systems to communicate between each other. So there will be a lot of inconsistencies. Now, to go around this, we can use a specification that is known by all of the CI/CD systems to talk between each other. This is where CDEvents comes in. CDEvents gives descriptive events or prescriptive APIs, and there are shared semantics which it provides, which can be used to talk between different CI/CD systems. There are different semantic buckets that we can think about that can be used to define different events in the lifecycle of CI/CD. For example, the very core of CI/CD is running pipelines and tasks, and there are events related to that. There are events related to source code version control events, which are specific to any repositories, branches, or changes. For example, if a PR is created on a repository, or a repository is created, or a branch is created or deleted, all life cycles related to social version control tools. Then there is continuous integration events such as builds, tests, artifacts. For example, the build started, build got deleted or stopped, tests started, completed, failed, artifacts such as images being created or not, and then based off of that, there are continuous deployment events as well, where an environment is created for a specific service to run in, or a service has been created in a specific environment. Now let's use what we've learned about CDEvents and see how we can set up CDEvents for Spinnaker and some other CI/CD tools. Some things to remember about while implementing this architecture is these are the things that we need to be aware of and see that we have before we go ahead with bringing the entire architecture together. For all the CD events that we have, we need a way to propagate these events throughout the system. The first thing we need is a broker which will take all the events and let everyone else know, or the triggers in that system know, that this event has occurred. For example, if a PR is created, the broker should know about this and then let all of the triggers in the system know about this. Triggers which understand that they need to do something on this particular event will run, the others they will not follow. Other things that we need to know is not all CI/CD systems are supporting CD events, so they need to have providers. And it is better to create providers for a CI/CD system than to completely onboard a new CI/CD system and migrate to a new one. You can just create a provider, and then all you need to do is carry out your new workloads over there. And with the old ones, you can still work on the old CI/CD systems without breaking anything. Now, what are these CD event providers? CD event providers would be providers which convert normal events to CD events, which see to it that events in those CI/CD systems aren't silently completed or failed. So that on each of these a CD event should be put out, and the system knows which action to create with which event. What I mean by this is which CD event is created on which action taken by the CI/CD system. Now, to understand better how CD events can be propagated through the system, we are going to look at this example architecture, which uses Knative for the broker and triggers, then Tecton as one CI/CD system, Spinnaker as the other CI/CD system, Uffizzi as a previews environment, and we have CD events providers for Uffizzi and Spinnaker. And Gray over here mentions the CD events which are created, and then we also have a CloudEvents player which is being used to see all the events that are coming in and out of the system. As you can see, the first thing that happens over here is a change created event is created. Now, what is this event? This event basically is when a pull request is created to GitHub or a merge request created to GitLab, this event should be created. And this has an ID, a source, which is the link to the repo itself or to the PR, and the repository where this is happening. For, as you can see over here, the ID of the repository would be your org name / the repo name. Once the pull request is created and the change created event is sent out, the Knative triggers a CD event via the Uffizzi CD events provider. This CD events provider lets Uffizzi know that it needs to create a preview environment for the PR, where the PR can be previewed and a full stack environment can be tested, which will be similar as the when a PR is created and a change created event is broadcasted by the broker, the first trigger knows that it needs to create a the first trigger knows that it needs to let the Uffizzi CDEvents provider know that this trigger has been created, and then the provider will let Uffizzi know that it needs to create a preview environment for the PR itself, and this preview environment will send a environment created event once the environment is created, and it will let the broker know about that. In the environment created event, we will have the source of the context of the environment. We'll have the name. In this case, it will be a preview environment, so the name will be preview, and the URL to the environment itself, which will be the Uffizzi URL. Now, when the user is done checking the environment and seeing the full stack preview of their application, they can now go ahead and review the change and then merge the change. Once a change merged event has been created, a CD event has been created, this is sent to the broker, and the second trigger, which is waiting on this event, will know about this, and the change event basically says that this is the source of the repo which has been merged, and this is basically the event. In other metadata, if this is a release event, what will happen is, in this case, what will happen is a build will be created through Tecton. So a Tecton event listener will pick up on this event and trigger a Tecton pipeline build and push pipeline run, and this will, after the run, send a build finished event, which will set out the last trigger that we have over here. The last trigger will basically trigger Spinnaker to create a final deployment of the application. It will take the, if you can see here, it will take the artifact ID from the build finished event and then send it over to Spinnaker, and Spinnaker will take this artifact ID, and then based on this artifact, it will create the new deployment. Once a new deployment is created, the CDEvents provider for Spinnaker will create a service created event and let the broker know about this. And the service created event will basically have the endpoint to the service itself. Over here, you can see that the CloudEvents player gets all the events from the broker. So you can see that the CloudEvents player basically collects all these events and you can see them. It also acts like a source. So if you want to send events to the broker, you can do it through the CloudEvents player. Now, to give an example of how some of these events are triggered, we can mock one of these events into the broker. Here I'm running in the CloudEvents player, in the Tecton pipelines namespace, I'm going to run an event which says that my PR has been merged, and I'm going to send it to the broker, which will trigger a Tecton pipeline. You can see that this is the event that I sent over here, and the Tecton pipeline has been triggered, which will create a build and push it to the registry, and then send a build finished event. If I come over here, you can see that this is what these triggers look like. This is the trigger that we've just triggered. The trigger for Spinnaker will look something like this, where it will listen on a dev CDEvents build finish trigger, and then we will trigger the Spinnaker service. In this case, it will be the Spinnaker CloudEvents provider service, and this is what it looks like to trigger Uffizzi environment. So it will be listening for like PR changes and then trigger the Uffizzi CDEvents provider. You can find all of this in my repo on Wavy Waves Spinnaker CDEvents Uffizzi, where you can see the ongoing work of creating a POC between all of these systems together. Now that we know how CDEvents can be used to interoperate between different CI/CD systems, we now know that we can use it to just interoperate, and without having to move to the other CI/CD systems, we can just interoperate with least amount of overhead. If you're using Spinnaker, you can continue using Spinnaker and still use other CI/CD systems along with Spinnaker and be able to interoperate between these two. It's better to create a CDEvents provider for a CI/CD system than completely onboarding a new one and moving to it. So thank you for attending my talk. It was great to have you here, and do go to my GitHub repo and go to the repo Spinnaker CDEvents Uffizzi, where you will be able to see a proof of concept of how to implement Spinnaker with CDEvents, Uffizzi, and Tecton. See you soon.